Graphing inequalities in two variables. This is chapter 5-6 found on page 317 of your textbook. Our focus today is going to be on graphing with two variables, x and y. But before we get to that, let's do a review of how we would graph inequalities with one variable. If I asked you to graph x is greater than 2 and you were to do it on a number line, then you would find 2 on the number line. Because it's greater than, it's going to be an open circle, which means that 2 is not a part of the solution, it's everything above 2. So you do an open circle at 2, and then we shade to the right, which means everything above 2 and above, everything above 2 would be part of the solution for this inequality. If I ask you to graph x is less than or equal to 4, then again we would find 4 on a number line. Because it's less than or equal to 4, 4 is also a part of the solution. So this time I fill in the circle because 4 is part of the solution. And then I would go everything to the left. We could take this same idea and we can put this on a coordinate plane. If I were to go back to this, x is greater than 2. If you drew your x and y coordinates like this, y, x, here's 2 on the x-axis, and you could just pretend that this is a number line. Here is 2 on the x-axis. So if I'm graphing everything greater than 2, I would draw a line through 2. And notice I'm using a broken line or dotted line just as I use an open circle. And then I would shade everything to the right, because everything in the shaded region, everything going to the right of this line would have x values greater than 2. So again, I use a dotted line and I shade to the right because it's greater than. Let's take the same idea over here for x less than or equal to 4. So I would draw my coordinate plane, and again it's on the x-axis, so that's y, that's x. So on the x-axis I look for 4, and because it's less than or equal to, this time I'm going to draw a solid line, just as I did a filled-in circle here. I'm going to draw a unbroken or solid line, and less than would mean everything to the left. So everything to the left that's in the shaded region would have a x value or x coordinate less than 4. The same is true if we were to do it on the y-axis. So for example, if I have y is less than 3, I put my x and y axes, so that's my y, that's my x. And then for y less than 3, I find 3 on the, oops, there should be let's do this with a different color. I find 3 on the y-axis, but this time I'm going to do a broken line because it's less than 3. When it's less than or greater than, we do only a broken line. And then because it's less than, I would shade everything below the line. And that would be my graph of y is less than 3. And I'm graphing it on the xy coordinate plane. So that's for one variable. If I gave you two variables, like if I give you something like 2x plus 3y is greater than 6, this equation is in standard form. So we're going to graph it the same way as if we would graph 2x plus 3y equals 6. So let's pretend it's an equation. We graph it in the same manner. We find the x and the y intercepts. So again, let's do this to the side. If I have 2x plus 3y equals 6, I can find the x-intercept by making y equals 0. So I'm going to put y equals 0, so that becomes 2x plus 3 times 0 equals 6. So 2x is equal to 6, x is equal to 3. So I know 3 is my x-intercept, okay? We do the same thing for the y. So the equation is 2x plus 3y equals 6. This time we're going to make x equals 0, and we're going to solve to find y. So we get 2 times 0 plus 3y equals 6. 3y is equal to 6. So we know y is equal to 2. So on my y-axis, I find 2 right there. Now, let's go back to it being an inequality. If it was just an equal sign or an equation, we would just draw a regular line through it. The only difference here, for greater than or less than, we're going to draw our broken or dotted line as we did earlier. But for greater than or equal to or less than or equal to, we draw a solid or an unbroken line. So the only major difference is it going to be a broken line or is it going to be a solid line? Now, because this equation had greater than, then it's going to be a broken line. So I'm going to draw a broken line through my two intercepts, my x and y intercepts. Okay? So now that I have my broken line through that, the next and final thing, it's greater than. And because it's greater than, generally we shade above for greater than. But here's how we can test to see if that is correct. We can take a coordinate point and test it. So I'm going to write test a point, and we're going to test the origin. And the coordinates of the origin is 0, 0. What do I mean by this? When I plug in x equals 0 and y equals 0 into my inequality, let's see what happens. So I take 2x plus 3y is greater than 6. So that becomes 2 times 0 plus 3 times 0 is greater than 6. So I get 0 plus 0 is greater than 6. So that's 0 is greater than 6. Is 0 greater than 6? No, that's not true. 0 is not greater than 6, so this is a false statement. So when I plug in 0, 0, which is the coordinates for the origin, into this, I get a false statement. What that means is that the origin is not a part of the solution. Origin is not part of the solution. So, going back to my graph up here, it means the origin is not a part of the solution, so I need to shade the side of the line that does not have the origin in it. So this is the side that I would shade. Okay, so let's quickly review what I did. 1. The inequality is in standard form, so I found the x and the y intercepts, as we normally would do for an equation. So after finding the x and the y intercepts, the next thing is, do I use a dotted line or do I use a solid line? And I use a dotted line because it was only greater than. If it's greater than or less than, we use a dotted line. And then the next thing is, which side of the line do I shade? Do I shade above for greater than, which we did, or do I shade this side of the line? And what we did was we test the origin. So plug in 0, 0, x equals 0, y equals 0, solve and see what you get for your inequality. If you get a false statement, it means that the origin is not a solution. If we had gotten a true statement, let's say we got 2 was greater than 1, which is true, then that would mean that the origin is part of the solution, and that would mean that we would shade this side of the line that has the origin in it. We did one problem here using standard form. We would do the same thing using slope-intercept form. Let's quickly do that. Let's say I had y is less than or equal to negative 2/3 x plus 1. This equation is in slope-intercept form, so we're going to use two things. We're going to use the slope of negative 2/3 on the y-intercept of 1 to make our graph. So here we go. Draw our x and y coordinates, x and y axes rather, and my y-intercept is 1, so I start at 1 on the y-axis. My slope is what? Negative 2/3, which means I'm going to rise negative 2, and then I'm going to run 3. That means I'm going to go down 2, so I go 1, 2, and then I go across 1, 2, 3, and 3 would be right there. Okay, so my point is here. So I have these 2 points, that right here and that right there, using the slope and the y-intercept. But let's go back to the problem. The problem says y is less than or equal to. So what kind of line am I going to use? A solid line. So I draw a solid line through those 2 points. The last thing to do is, which side do I shade? Do I shade above or do I shade below? And generally when it's less than, we usually shade below the line. But just to make sure, let's again test the origin. What do we mean by that? We're going to plug in x equals 0 and y equals 0 into the inequality and see what happens. So I have y is less than or equal to negative 2/3 x plus 1, y is 0, and I'm going to replace x with 0 plus 1. So I have 0 less than or equal to, that term 0 is 0 plus 1. So I have 0, and 0 plus 1 is 1. So now I end up with 0 is less than 1. Is that true or false? That's true. So since we have a true statement, it means this origin is part of the solution. 0, 0 is part of the solution. Hence, we shade the side of the line that has the origin in it, 0, 0. And that's how we graph inequalities in 2 variables. I hope that helps. So graphing inequalities, 2 variables. See ya.